In this video, we're going to begin our discussion with probability. So, probability is the measure of the likelihood of a chance behavior occurring. It deals with experiments that yield short-term results, yet try to predict long-term results. So the outcome is a result of a random experiment. An experiment is a process with uncertain results that can be repeated. So, some examples of experiments. Suppose I pick a card from a standard deck of cards, not replace it, then select another card. What's the probability that I will select at least one queen? Or, suppose I have 20 people in the room and ask them when their birthday is. What is the probability that 2 people will have the same birthday? All right, so the sample space is the collection of all possible outcomes. So the sample space is written in set notation using braces. Well, braces, remember, are these. So let's take a look at a couple of examples. So write the sample space of rolling an 8-sided die once. So usually a normal 8-sided die have numbers 1 through 8 on it. So the sample space would be writing out 1 through 8. S for sample space using braces. Write the sample space for flipping a coin twice. Well, certainly I could get heads, heads, tails, tails. I could do heads, tails, and tails, head. Okay, so an event is any collection of outcomes from a probability experiment. An event consists of one or more outcomes. So an example, suppose you roll an 8-sided die once. Define the event E equal to rolling a number greater than 3. So the event, rolling a number greater than 3, would be 4, 5, 6, 7, and 8. Again, notice it's in braces. All right, there are 3 types of probability we will discuss. Empirical probability, classical or theoretical probability, and subjective probability. Let's start with empirical probability. That's the number of times event E is observed divided by the total number of trials of the experiment. So again, probability with respect to E is a frequency of E divided by the number of trials of E. So let's do an experiment. This is a question that's caused many fights and arguments with family and friends throughout history. The big important question, no, nothing related to religion or nothing related to politics. What am I talking about? Of course, I'm talking about Coke versus Pepsi. So suppose I do this experiment and I get the following results. 9 like Coke, better than Pepsi. There are 7 people that like Pepsi better than Coke. And 4 people that like neither. So understand, when I ask the question, it's either Coke or Pepsi. They could not pick both. But if they're not a soda drinker, they have the option of picking neither. Okay, so what is the probability that a person likes Coke? So the probability of Coke, well, how many people like Coke? That's 9. Total number, that's 9 plus 7 plus 4, that's 20. So the probability that we will select one person that likes Coke is 9 out of 20. What is the probability that a person doesn't like Pepsi? Well, there's a couple of different options that we can do for this. So if we're doing the probability of not Pepsi, certainly that's the probability then of liking either what, Coke or neither. Well, that's the probability of Coke plus the probability of neither. Well, we already know that 9 out of 20 like Coke. Adding the neither, that's going to be 4 out of 20. And that's going to be 13 out of 20. Now, that's one way to be able to do this. The other way that I would recommend, I'll put up here, the probability of not Pepsi can also be written as 1 minus the probability of somebody liking Pepsi. Well, that's 1 minus people liking Pepsi. That's going to be what? 7 out of 20. That can be written as 20 over 20 minus 7 over 20, which is 13 over 20. This is what is called using the complement, and this is what I would recommend using when I see words like doesn't like or not including something. Okay, one other example. How about the probability that a person likes either Pepsi or likes neither? So the probability of Pepsi or neither. When I see the word neither, I'm going to add. So it's the probability of Pepsi plus the probability of neither. Probability of liking Pepsi is 7 out of 20. Neither, that's going to be what? 4 out of 20. And that's going to be 11 out of 20. Now, notice this was a very, very small sample. So if I want this to be more accurate, I would want to sample more people, thousands and thousands and thousands and 10,000s of people to get more accurate results. And that's what the law of large numbers reinforces. The law of large numbers, as the number of repetitions of a probability experiment increases, the proportion with which a certain outcome is observed gets closer to the probability of the actual outcome. Okay, so now we've taken a look at empirical probability. Let's take a look at classical, or what's called theoretical probability. That's the number of ways that E can occur divided by the number of possible outcomes. So the probability of E is written out. Now, it looks exactly the same type of formula as empirical probability. Empirical probability, you are doing the experiment. Classical, you may not necessarily be doing the experiment. So what makes it different? With classical probabilities, outcomes are equally likely to happen. When we took a look at our previous example, the probability of somebody choosing Coke and Pepsi were not exactly the same. The probability of somebody picking Pepsi and neither were not exactly the same. With theoretical, each particular outcome is equally likely to happen, since you're not doing the experiment. Okay, let's take a look at an example. So suppose you roll an 8-sided die once. Calculate the following probabilities. So remember, we've already done the sample space. We know that's going to be 1 through 8. So there's 8 different possible numbers that I could get. Well, the probability of rolling a 7, well, there's 1 7 on an 8-sided die out of 8. There's the probability. The probability of rolling a 4, 5, or 8. Remember, I see an or, so that's the probability of 4 plus a probability of 5 plus a probability of 8. So that's 1/8 plus 1/8 plus 1/8. That's 3/8. Well, what's the probability of rolling an even number? Well, that's the same thing as what? The probability of a 2 or 4 or 6 or 8. So that's going to be 1/8 plus 1/8 plus 1/8 plus 1/8. 4/8. Make sure you reduce in the lowest terms. That's 1/2. What's the probability of not rolling a 2? So I'm going to set this up using the complement. This is the same thing as 1 minus the probability of rolling a 2. Well, that's 1 minus the probability of rolling a 2 is 1/8. 8/8 minus 1/8, that's 7/8. The probability of rolling a 10, well, there's no way to roll a 10 on an 8-sided die, so that is 0. And then part F, rolling a value greater than or equal to 1. Well, that's every single number. That's 1, that's 2, that's 3, all the way up to 8. So that's what? 8 over 8, which is equal to 1. So, some rules for probability. The probability of an event occurring is certainly going to be less than or equal to 1, thanks to part F, but it's always going to be greater than or equal to 0, thanks to part E. So having something less than 0, a negative number, doesn't make sense, and the probability of something greater than 1 doesn't make sense either. So the sum of the probabilities of all possible outcomes is equal to 1. Let's take a coin, for instance. The probability of getting a head is 1/2. The probability of getting a tail is 1/2. 1/2 plus 1/2 is equal to 1. So when you add up all the possible outcomes, it should always add up to equal 1.